Now this is the summary of last video, and today we will talk about some other basic concept. These are the basic concept which I will talk about in this video. Now we are starting from uh, macroscopic study viewpoint and microscopic study viewpoint. So there are two point of view mainly from which the behavior of matter can be studied. Now this is macroscopic viewpoint. So from the definition of macroscopic viewpoint, uh, a certain quantity of matter is considered. Suppose this is my quantity of matter. So means we focus our attention to certain quantity of substance without going into the event occurring at molecular level. Okay, and we see the changes on substance by taking the whole mass. So suppose the force is acting on it, so I will see the displacement in it. Okay, I will not see the molecular activity of this substance. So the displacement what I will see. Now the second thing is how to measure this. Effect can be directly sensed by human senses and easily measurable. Means I have a container, suppose, which is closed and the gas is filled in it. So a container having gas inside it like this. Now I can easily measure pressure, volume, temperature. Pressure by pressure gauge, volume by its length into area, and temperature by thermometer. So we can easily measure the properties in microscopic viewpoint. Okay, now what will be the microscopic system then? When a system is explained by large scalar quantities, large scale characteristics or properties of the system, then it will be the macroscopic system. Now come on to the microscopic view. From the microscopic point view, matter is combined of myriads of molecules. So suppose this is my matter. So there will be many molecules in it. Okay, so as we know that the matter is combined of myriads of molecule. So the behavior of gas is or substance is described by a certain quantity of matter from its molecular action. Okay, so in this viewpoint we see the molecular action of a system. Suppose again I apply the force, then what I will see? I will see the displacement in molecules, not in a whole substance. I will see the uh, behavior of molecules in this. Okay, और अगर बात करें कि इसको मेजर कैसे करते हैं, so it can't be perceived by human senses. Okay, because it is complicated to measure the property like velocity, moment, kinetic energy of each and every molecules in a system. Okay, so there will be lots of calculation in it. So that's why it is also known as statistical viewpoint. Okay, statistical viewpoint, and this is statistical viewpoint, and this is, we may say, macroscopic viewpoint or classical viewpoint. Now come on to the property. So there are different properties which are some of our intensive property and other are extensive property. So the properties which does not depend on mass means independent of mass. So the properties which does not depend on mass are called intensive properties, and the properties which depends on mass will be extensive properties. For example, intensive properties like pressure, volume, sorry, temperature, okay, specific volume, specific enthalpy, specific entropy, right? So these are the intensive properties. So how we can identify that these are intensive property? So if a system is divided into some parts, in two equal parts, suppose if a mass is divided into two equal parts, then we see the changes of properties. Okay, if there are no changes in it in property, so that will be the intensive property, because when we are doing half of all the mass, then there will be no change in properties, so that property will be intensive property. And if the property in which the mass is divided into two parts and they are changing, so those properties will be extensive property, because they are varying as mass changes. Okay, so intensive property, so if I divided it into two parts, so pressure will remain same, temperature will remain same, specific volume, specific enthalpy or entropy will be same. One more example is density. We know that density is equals to mass upon volume. Here we see mass in its formula, but it is intensive property, because when two extensive properties are divided, then it always gives a intensive property. Okay, now extensive property which does not depend on mass. So example will be like volume, energy, enthalpy, entropy. Okay, so for example, now this is our extensive property. There is one more thing, that all intensive properties are specific property. Means if I have to make, mostly what we do is we make the graph between the pressure and volume, and both the properties should be intensive property. So to make the volume intensive, we divide it by mass, and then we will get the specific volume, as you can see in an example. Okay, so these were the examples. So same case for enthalpy. When enthalpy is divided by mass, we'll get specific enthalpy, means intensive and property. Okay, now heterogeneous system. Heterogeneous system is a system which is consist of one phase only, like nitrogen plus oxygen. So there are gases in it, means only a gaseous phase in this example. So that will be heterogeneous system, means system having one phase only will be heterogeneous system, and a system consisting more than one phase will be the homogeneous system, means system having more than one phase. Okay, for example, ice plus water will be the homogeneous system, because there are more than one phase, liquid phase plus solid phase. Okay,